Hello and welcome to a screencast about the vertex form of a quadratic function. All right, first problem here says graph the quadratic function. F of x equals 2x squared minus 4x plus 3. This is obviously not in vertex form, as we will see down here below, but we can still graph it by hand. You can obviously graph it on Desmos, but trying to translate it over onto your paper is going to be kind of difficult. So thinking back to a previous video we saw, so remember these are of the form ax squared plus bx plus c. Okay, so thinking about the different pieces here, we know that 0, 3 is going to be our y-intercept, right? Because if we shove a 0 in everywhere, that's going to pop out a 3. So I can go ahead and plot that point. And I want to try to be fairly accurate here. Bear with me. Then let's see, we know our vertex. The x value of our vertex is negative b over 2a. So my negative b, so b is negative 4, so negative 4 is going to be positive 4 over 2 times my a value, which is 2. Oh, so that turns out to be a nice one. Perfect. Then I need the y value of my vertex, right? Because I need to know how high up to plot this point. So I can figure out what f of 1 is. So if I throw 1 into my function, I end up getting 2 minus 4 plus 3, so that's negative 2. So I believe that's also 1. Okay, and hopefully my mental math there is correct. Yes, I believe so. All right, so then that means I can plot the point 1, 1. So that's going to be here. Oh, but this is a quadratic function, so you typically need 3 points to accurately graph a quadratic function. How are we going to get another point then? Well, remember that there's that thing called symmetry, right? And we know that we have a vertical line here that goes through that vertex. Pretend like that's actually vertical. And then we know that that's symmetric, right? So I know I'm going to have another point over here, here-ish somewhere. So let's figure out exactly where that here-ish is. So I know that the distance between this intercept and my line of symmetry is 1. So that means I need to go 1 to the right of my line of symmetry. So my here-ish was actually pretty accurate. Okay, so those are my 3 points, so I can make my parabola. Ooh, okay, I guess that's pretty good. All right, so we know then down here to remind ourselves what the vertex form of a quadratic function is. And I don't want to go too far because I need to use some of this information up here again. A quadratic function with a vertex h comma k. So thinking back to our example that we just did up here then, that means that our vertex was at 1, 1. Okay, so maybe written in the form y equals a times x minus h quantity squared plus k. The constant a may be determined from the other function value for an input where x does not equal k. All right, so for our case, that doesn't really matter. We'll see where that one goes. So we know that a has to be this number sitting in front of the x squared, right? That's how these things work. So my f of x is 2 times the quantity, x minus, and again, you'll notice with this vertex form, there is a minus sign built into those parentheses, just like we did with the point slope form of a line. Same thing there. So my h value is 1 squared plus my k value is also 1. Okay. There's other ways you can find this too, like you can do some completing the square or some other fun algebra, but we might as well use the graph if we got it. Speaking of graphs, okay, here is a funky looking graph. No, it's not too funky, but it's just a random parabola kind of floating off in space here. And I want to find an equation in vertex form of the quadratic function graph below. Okay, so vertex form, we definitely need to remember then. So that was y equals a times x minus h squared plus k. Okay, so I need 2 pieces here. So I need to know my a. Well, thinking back to a previous video, this parabola opens down. So we know a is negative, but I have no idea negative what. Okay, we'll get to that later. And then we need to know where the vertex is, because remember, that's our h comma k. That we can find, thankfully. I made it happen here at a nice point. So my vertex is at the point -2, -1, -2. Because my x value here is -1. Yep, so that's a 1 there. Okay. All right, so I got my vertex. So let's go ahead and plug that in. We'll start there. So y equals a times x minus a -1. So that's going to end up being +1 squared minus 2, because that's my k, or plus a -2 if you want to write it that way. So now how on earth do we figure out what this a value is? Well, x and y, remember, is just some point on this parabola. So do you guys see any other nice points on this parabola? Yeah, I think so. I like to use my y-intercept if it's nice, and I think it is. So this is another point on the graph, 0, -5. So I can plug that in. That's my x, that's my y. Remember, this is a function, so any point on that function should work. So -5 equals a times 0 plus 1 squared minus 2. So now we just got to do a little bit of algebra and figure out what that a value is. So -5 is a times, that's 1 squared minus 2, so -5 is a times 1 minus 2. Or you can just say a. So we can add a 2 to both sides to wipe that guy out. So -3 equals a. Okay, times 1 divided by 1 if you really want to, but you don't need to. All right, so to finish off this problem then, so I'm going to go back up here to this where I was at before, and then I'm going to plug in my a value. So y equals -3 times x plus 1 squared minus 2. And it's always a good idea to go to Desmos or whatever your favorite graphing utility is, throw this equation in and make sure it actually matches. All right, thank you for watching.